So in this example, we're going to use R to analyze whether or not a data set is from a normally distributed population. So we first need a data set. I happen to have an example that just happens to have some data, and I'm looking to see if it's normally distributed. So I will, again, it's easier to copy the data, so if you can just copy the data and paste it into R, that's preferable. So I'm going to copy that data into R, and I just called it X. One of the first things we look at is a histogram. A histogram is just hist, and then your variable. When I plot that up, I get this. That looks fairly good. If you want to, you can change the number of classes it created. You can also put a better title if you want. You can make a color if you don't like it to be in the gray or the white that it's in right now. But this is fine as it is. If you want to change the number of classes, you could say I want to only have 6 classes. And then if I go to look at this, R pretty much uses that, didn't change anything, but R pretty much uses that as kind of a guideline. It will figure out whether or not it thinks the number of classes you want will work for the data set, and if it doesn't, it'll use kind of a similar to that. If you want to, you could change it to 4 and see if it changes the graph at all. You play around with this a little bit till you get a better idea. That doesn't give me as much information as the 6 did, so you can change it around and change it as you need to. So I probably would go back to the 6, and looking at this histogram, it looks like it's, you know, it's not perfectly normally distributed. It's, or I should say bell-shaped is what we're looking for. There is this high line here, but it's not that bad off, so it might be okay. Another thing we look at is the number of outliers. The easiest way to find the outliers is just to do a box plot. You can just do a box plot of your variable. I'll go look at what that looks like. I happen to like my box plots to be horizontal, but right now all I'm really caring about, and it should have a title and an axis label, but all I'm really caring about at this point is how many outliers does it have. And this dot here shows me that there looks like there's only 1 outlier. There could be 2, because there could be 2 dots that are exactly on this spot. But from the looks of this modified box plot, it looks like there's only 1 outlier. So we're okay. So we've got a histogram that sort of looks normal, bell-shaped. We have, looks like only 1 outlier. And then the last thing we should look at is called the normal probability plot, or the normal quantile plot. And that is a QQ norm, is the way we do that, of my variable. So you just type in QQ norm of your variable, and then we'll go look to see what that graph looks like. And this is what a QQ norm graph should look like. You don't have to worry about your labels. It will automatically put labels on here for you that make sense for it. The idea of a QQ norm is, does it look somewhat linear? So could you draw a line that kind of fits this data? And this one looks like it does look linear. If I started this dot and drew a line through here, I'd get close to this dot and have all the other ones in there. So this one does in fact look like it has a normal probability plot or normal quantile plot that is linear. So given that the normal quantile plot is linear, the histogram looks somewhat bell-shaped, and there's only 1 outlier, I would say that this data set came from a population that was normally distributed. I will never know for sure, but that would be my guess.